In section 3.7, we're going to talk about equations with two variables and their graphs. So far we've worked with equations that had one variable, and you were looking for the solution to that equation. In other words, you were looking for the one value of that variable that would make the equation true. So sometimes we want to represent the relationship between two variables. This comes up a lot in the world. And so we're starting into working with equations that have two variables in them and talk about the relationship between the two variables. So given one value of one variable, we figure out the value of the other variable. And as a part of that, graphing is helpful because graphing is a quick visual way of representing the relationship between these two variables. So let's look at an example of that. So if you're at an hourly wage job or you make $11 an hour, if we set two variables, H is the hours worked and T is your total wage, then you end up with this equation here that shows us what the relationship between those two variables is. To find the total wage, you're going to take 11 and multiply by the number of hours. So this is an example of what we mean by an equation that relates two variables. No matter what number of hours you work, you can find a total wage that's associated with that. If you work 1 hour, your total wage will be $11. 2 hours, $22. If you work 3 hours, your total wage will be $33. So it's just a constant set of relationships between these two variables. So here's another example. We have two people, William and Eric, and a relationship between their age. So if you look at this, when William was 1, Eric was 3. When William was 8, Eric was 10. When William was 23, Eric was 25. So you look at that and pretty quickly you can work out that Eric is 2 years older than William. And the way we write that mathematically is this equation. Remember, that equation would have no meaning if we didn't define that E is Eric's age and W is William's wage. William's age. So if E is Eric's age and W is William's age, then this relationship shown in the table shows up as E equals W plus 2. And for as long as both of them are alive, that relationship will stay the same. So earlier, when we talked about simpler equations, when we talked about finding the solution to this equation, remember that what we meant by that at that time was what value of x could we put in there to make this true, because remember that equal sign is a statement of fact. So we're saying x plus 5 is equal to 9. So what value of x would have to go in there to solve that equation? And of course we did that by doing the done undo procedure, and so we find that x equals 4, and that is the solution to that. It's the only number you could plug in for x and make that true. So let's go back to our equation about Eric and William's age. So what would a solution to that equation be? Well, there's not going to be just one solution, because remember that it's the relationship between the two people's ages. And so the solutions are going to be pairs of numbers, the ones we showed in that chart. So one solution is when W is 1, when William is 1 year old, E is 3. So Eric will be 3 years old. So the solutions don't come as single numbers, they come as a pair of numbers. The idea of a solution is still the same, that a solution is the number that makes the equation true, but now we've got two variables in there, and so there'll be pairs of numbers that make it true. So sometimes we want to check and see if a pair of numbers is a solution to an equation. So we want to know if this is a pair of numbers that'll solve that equation, W equals 10 and E equals 12. And the way we want you to do that is take the original equation and replace the variables with parentheses. So this might seem needless, but this is where people start making mistakes with signs, especially when you have things like negative numbers being squared, and so really take our advice on this and replace the variables with parentheses. And then you just plug in the numbers in their proper spot. So remember, we're up here checking to see if this is a solution. And so we put 12 in for E and 10 in for W. And then we're asking, we're not saying yet that this is true, we're asking whether it's true. Turns out it is true, so we know this pair is a solution to the equation. So this is the official version of that. Solutions of an equation with two variables. A solution to an equation with two variables consists of a value of x and a value of y that make the equation true. We can write the solution as an ordered pair x, y. So those ordered pairs that you worked with a little earlier, that was leading us up to this. So again, if we're going to check to see if something is a solution to an equation, your book has has the method in it. So if we want to check and see if 5/17 is a solution to this equation, so the 5 is the x, and because remember this is an ordered pair x, y. So that's how we know the 5 goes in here and the 17 goes in here. And remember, at this point we're asking whether this is true. We're not saying it's true. So now down here I'm going to cross this one out. So we're going to go right to the next step. 17 equals 15 plus 2. Is that true? Yes. So that means, yes, this is a solution to this equation. So that ordered pair 5/17 is a solution to that equation. So let's try a slightly more difficult one. This is one where you really want to make sure that you do the procedure where you replace the variables with open parentheses. So that's the first step, is to just write with open parentheses, and now we're going to write in the variables. So y is 12, x is -4. So we're asking the question of whether that's true. So then the question is, -4 squared is 16. So is that true? It's not true. So this is not a solution, because those numbers did not make a true mathematical statement.